Okay, in this video, we're going to talk about fraction decomposition, rational inequalities, and complex fractions. We're going to take a fresh look at complex fractions. But first, fraction decomposition. Decomposition meaning take it apart. But before we look at that, we're going to put them together. And I think first thing to do is to remind you that before you combine two fractions together, they have to have the same denominator. You know that this is not the correct answer, right? Because the denominators are not the same. How do we make them the same? Well, in this case, 9 and 4 do not share any common factors. So only thing you can do is multiply each of the denominators by the other one. But we do the same in the numerator as well, so that we're only multiplying by 1 and not changing the problem. So once we do that, we're able to add the numerators. That's 16 plus 18. 16 plus 18 would be 34. Main point being common denominators before adding or subtracting fractions. Okay, well, first stop at our level of math, we're looking at an equation that has binomials as our denominators. And as binomials, factors in and of themselves, they're clearly not the same. Well, these two are the same, but each of them needs one or the other in order to have them all the same denominator, to give them the same denominator. So this one needs that one. I'm going to write it underneath. This one needs that one, and this one needs that one. But the important thing is that those denominators that each term does not have needs to be added up there. So this one needs the x minus 4 because it didn't have that in its own denominator, and this needs x plus 4. But the key thing to know when you're solving an equation is that once all the denominators are the same, they can be eliminated. Because you can solve a problem, any equation, as long as all the denominators are the same, right? 3/7 is just 2/7 plus 1/7, because this is true. So if that had been x, you'd be able to solve this and know that x is 1. That's all you need to do to make the sentence true. So in the end, for this rational equation, we have, I'm going to write this on that side because it's a little bit more natural, equals 5x minus 4 plus x times x plus 4. Okay, we basically, now when we've made all the denominators the same, the numerators change, but we can now just focus on the numerator and solve for this. Now, how do we do that? Well, we multiply everything through. We are going to have a quadratic when I multiply these two, and quadratic calls for a different strategy. You have to be a little bit more strategic. And I think in this case, what will be best is to move all the terms to one side and leave 0 on the other. I don't know which side it's going to be. But let's multiply all this through. X, there's our x squared. You know what? Let's move. Well, before we do that, we should combine like terms. That'll make things a little bit cleaner. This term and that term are like. So, and let's standardize this by putting the terms in descending order of powers. Okay, and then let's remove what's on this side to make this side 0. And in doing so, we get and here we have a trinomial that can be factored. This is, if we use our old x method, well, given that the a here is 1, whatever we get here and here will make our binomials. And it looks like we can use positive 8 and negative 6. X plus 8. Don't skip this step. Don't think that these are your answers. Don't be too hasty. Those are not your answers. These are the terms that you use to make your binomials, and the binomials must be set to 0 for you to get your solutions. Your solutions will therefore be this and that. Those are your two solutions. Why two solutions? Because you had a quadratic equation. However, this is not fraction decomposition. This is kind of just a warm-up. So that you're used to these, to this process. This is fraction decomposition. You're going to be given a fraction. And in this case, it's already factored for you. You've got two plain factors here. And you're going to be asked to come up with two, this is doing the reverse, two fractions. One that has the first factor in the denominator, the other with the other factor in the denominator, and you need to come up with the numbers a and b that satisfy this equation. Okay? And don't think for a minute that a is 2x, b is positive 7. That's visually very appealing. You know it's not going to be that easy. You know, for example, hopefully you don't think this. I'm writing an example that falls into that same trap. Oh, here are two fractions that have each one piece of the denominator in the sum, and the answers are definitely not going to be 2 and 3. Okay, you can't just do that. This doesn't work out at all, because what is this? This is 5 over 6, and each of these are 1 plus 1. That does not, they do not equal each other at all, because that's 2. That doesn't make sense at all. But it just so happens that with a little bit of process, you're able to decompose 5 over 6 into 1/2 and 1/3. And by giving each denominator the other denominator that's missing, you can see why that would be the case. 3 plus 2, this becomes 3 over 6 plus 2 over 6. And that is where we get our 5 over 6. But when you're dealing with binomials and algebra and variables, of course, it's not going to be that simple. Here's the process. Okay. What you're going to do, like in the previous example, is give these two fractions the denominator that it doesn't have. Here are the two kind of denominators. This already has both, so we're kind of set there in terms of equalizing all the denominators. Let's give the a on top what it doesn't have, and I'm going to write this on the bottom just for now. We're going to scratch it out in a second, but this side needs x plus 3, which we're going to do on the bottom and the top. Okay, so I know I wrote this kind of one on top of each the other, but you can see that all the denominators are the same now, which means we can just focus on the numerator and write ourselves a new equation. Equals A. We're in search of A, but we're going to do a little trick and we'll be able to figure out what A is. Okay, this is a very kind of strange equation at first because you have three variables, not just X. Whoops, sorry. Not just X. We have A and B. Well, here's the trick we're going to play. We're going to designate X to be something that will eliminate this term. Okay? And so we're going to say let X equal 1. Why 1? Because when I make X equal 1, guess what that becomes? It becomes 0. So the A, it disappears. When we let X be 1, whoops, then we have this equation, 2x plus 7 equals B times x plus 3. Because we've just made this 0. Okay? But since we were just saying x is 1, let's go ahead and make x 1. There's an x, there's an x. Let's make it 1. 2 plus 7 equals b times, what is this? When x is 1, times 4. Okay? So what we're getting here, this is a little bit awkward, but we're getting 9 equals 4b. B is 4/9. Sorry, my mistake. 9/4 is what I meant. 9 over 4, divide both sides by 4. Okay, so B is 9/4. Okay, we've gotten one of our answers. Right there. Let's work on the A. And we're going to apply that same technique. You know what? Why don't we let x be -3? Why? Because we want this to disappear, making this disappear, and that's going to make our equation pretty simple. And we said x would be -3. When we make x -3 right here, that looks like that's going to become a -4. And when let's continue. X equals -3, that makes this -3. I kind of combined some steps. -6 plus 7 equals A times -4. -6 plus 7 is 1. I'm going to rearrange this. Divide both sides by -4. Here we go. A equals, I'm going to put the negative on the side, -1/4. Okay? So to complete our answer, when you're asked to decompose a fraction, you need to insert the A and the B back into each of the fractions. And when you have a denominator, if you have a denominator in your A and your B, that denominator, this will go down to the bottom. So in other words, A, we're looking at A being -1/4. Our answer is going to be that single term is decomposed into -1/4, and here's that original kind of partial denominator, plus 9/4, and here's the other part of the denominator. So our A is this. Oops, should include that sign. And our B is this. Okay, so that's kind of a lot of work, but it's very logical, and you just have to remember the tricks. Let's try another example. This is the kind of example you will see on the test, it's not going to be formatted where where the two fractions are split up and you're asked for A and B. You have to kind of just acknowledge, or you have to kind of set up your problem that way. Furthermore, in at least one of the problems, you're not going to see the two factors in the denominator. You're going to have to factor the denominator to get the two factors.